for track 1 with Understanding Genome Code of Conduct, which is COC, presented by Rosanna. So, have it away.
Thank you. Glad to see everyone here today. I know it's early on a Sunday, so I'm glad y'all could make it. First things first, this is a slide just to talk about the major takeaway I want everyone to have. If you have a code of conduct violation that you want to report, this is how you do it. I will show the slide again at the end, but this is the major takeaway that I want to make sure everyone knows. So it's really nice to meet you. My name is Rosanna Yoon, as Suzanne said. I've been running GNOME since the pre-1.0 days. I think my first version was 0.37. I was also the first female to submit code into GNOME, which it's still there. And so I've been part of the GNOME community since 1998, so long time ago. And I was hired by the foundation in 2006. I've been to many GNOME conferences and events, and I've seen a lot of folks come and go, and that's normal, right? All sorts of communities, people come in, people leave. So how am I still here, right? All this time. Luck. It really has to do with luck. I was really, really lucky. I started off in GNOME because my husband, who was my boyfriend at the time, was also contributing to GNOME. And he introduced me, and he was working on the desktop at the time, and he introduced me to it. And him and his team at work were all really, really great people, and they mentored me. I had problems with, like something didn't work, I had a bug. They helped me fix it, or they showed me how to file a bug report. If they taught me how to, do commits and all that jazz, right? So I was able to contribute because I had mentors. And mentors are really important. Completely different talk. I'm sure you've probably heard about that too. But the other thing this team did was that they protected me, right? These were upstanding members of the community, and they were there, and they kept me safe from bad actors, right? And they would, if you talk to any of them now, they probably wouldn't think anything of it. They'd be wouldn't exactly know what I'm talking about here, because they're just genuinely nice people, and it wouldn't have occurred to them that's what they were doing. But they would do things like casually mention people I probably didn't want to interact with, right? Known bad actors. And like at a conference or an event, if there's someone who started asking me questions or saying things that didn't make me comfortable, I knew I could always go to them and hang out with them, and just their presence there would stop a lot of this stuff from happening. So I was really lucky that they were there and helped me get comfortable inside GNOME. That being said, I still started drifting away in maybe 2002, 2003. They're awesome, they're great, they're also really smart people, and I hadn't really found my niche and didn't feel like I belonged. Like the code I wrote was, not like as important as what they did, right? They did like the base stuff that's super important. I was doing games, I was doing docs. It didn't feel all that important to me. But in 2006, I had some free time. I was expecting my first child. The GNOME Foundation needed some help. They just lost their executive director. They needed someone to come in and help with keeping their books in order, helping with paying all their bills, making sure they were running well. So they hired me temporarily. It's been 16 years. My child's in high school, and yeah, temporary in free software doesn't always mean a short period of time. Like if you write code and put it in temporarily, it might still be there. It's a thing. So why am I telling you my history? Like I said earlier, I saw a lot of folks drift away. And sometimes it's for a really good reason, right? They get a better job. like they get married, have kids, they just don't have time. It's fine. I understand. I'm happy for them. But sometimes they just drift away for other reasons, right? And the theme of the people who either stay or come back to GNOME tend to be the people who felt the most comfortable. So here's the thing. Not everyone can be as lucky as I was, right? I had all these people. I obviously from a group that's as diverse as possible. The more people that you don't welcome into your community, the harder it is to reach that community, right? For example, my son's left-handed, and just knowing that I can accommodate things for him, but still he comes up to me and say, hey, it would be easier if, right? So if you don't have that person in the room to help with writing the software, making events more inclusive, it's going to be very hard to get them to be users, okay? So, so the whole concept thing was with me and the code of conduct is that we were trying to create to ease the entry for newcomers into the community. We're trying to level the playing field, and the code of conduct was created to try and make that happen. A bunch of us felt that it was important enough to create and make a code of conduct that protected newcomers and folks already in the community alike. So the code of conduct has a wide-reaching scope. What does that mean? Ooh, I lost my notes, sorry. It has a wide-reaching scope. That means we cover everybody in the community. And by everybody, I mean everybody, right? It could developers, doc writers, translators, event attendees like you, event planners, even everyday users, right? All of us are part of the community, and we need to make sure that everyone feels welcome. The other thing that the scope covers is all the places where GNOME takes place. So, issue tracking, like in GitLab. Oh, are you okay? Okay. In GitLab, or discussions like on Discourse or in the GNOME Reddit channels, like chat apps like in Telegram or Matrix. Anything on GNOME.org infrastructure is covered, obviously. GNOME events are covered, and venues related to events. So if you're at a conference, GNOME Asia, for example, here, and you go out to dinner afterwards with people from the conference, you're still covered. So it doesn't have to be like in the actual talk, even afterwards surrounding the event, those areas are covered. So as I said before, it sets expectations as to what is acceptable behavior. It lets newcomers and long-time users alike know what we as a community believe is acceptable behavior and what isn't, right? So it gives something, if something happens, it gives people something to point to and say, look, as a community, we cannot accept that, right? It gives us something to measure actions against. So the next part of the code of conduct has our community guidelines. Be friendly, be empathetic, be respectful, be considerate, be patient and generous, and try to be concise. And I put a link to the code of conduct at the bottom if you want to refer to it yourself. These are aspirational. So this is not the meter stick that we use for code of conduct violations. So for example, if someone writes an email about their new app release and goes to great lengths describing all the wonderful things they did, but does it in a really neutral manner, it's going to be neutral. It's not going to be particularly friendly, and it's definitely not going to be concise, but it's also not a code of conduct violation, right? It's just, these are how we hope people behave, but we understand sometimes, like, you know, it's not what we measure the violations against. The next section are the inappropriate behaviors, and this is what the meter stick we use. This is what the Code of Conduct Committee will look at and say what isn't acceptable. Note that I did truncate them a little to fit them on the screen. So once again, if you go to the Code of Conduct page, it will expand on what each of these bullet points say. Safety versus comfort. That is the next section of the Code of Conduct, and it's also one of the more controversial sections. And individual safety is always more important than another individual's comfort. It seems pretty obvious, right? You want everyone to be safe. If just because it's, you know, in order to be welcoming, everyone as a baseline should feel safe. Where we get into problems is once we get into specific details, we get people saying, but it's always been that way, or I don't want to go out of my way to do this. That's really not acceptable if you want a diverse and inclusive community, right? You need to be able to somehow go out of your way to incorporate everybody. And more importantly, if you have person A making inappropriate comments repeatedly to person B, right? Leave them alone in stronger and stronger terms. It doesn't matter how rude person B gets. The Code of Conduct Committee is going to be looking at person A's behavior to begin with, because that was the unsafe behavior. But there haven't been that many issues, right? This is something a lot of people say to us is like, why do we need a code of conduct? We have had one for a few years, but like there's been very few issues, so maybe like it's not necessary. But really, why haven't we gotten that many issues? Is it because the code of conduct isn't well known enough? Is it because we lack trust in the Code of Conduct Committee? Maybe it's too hard to write a report. Maybe people don't. It's just too big a step for them to do it. And really, is it just easier for them to walk away from the community and have us lose that person? It's really, but these are the reasons why I'm having this talk here today. If you have any ideas on how we can improve the process, I'm all ears. So why should we trust the Code of Conduct Committee? There are currently 3 people on the Code of Conduct Committee. It's Tybalt Martin, who's the chairperson of the board of directors of the GNOME Foundation. There's Federico Mena, who's one of the founders of GNOME, and also one of the people on my husband's team in the back end, so one of the people I trusted from back then, and obviously still trust today. And then there's me. So we are the people you talk to at the moment if you're contact the Code of Conduct Committee. And I can tell you that I know these, both of them very well, and all 3 of us genuinely want to make GNOME a more welcoming and inclusive place. It's very important to all of us. Reports to the committee are confidential. We don't share who sends us reports. And if you want it to be anonymous, you can just send us an anonymous email. That's fine too. In cases where it's a one-on-one situation and you're afraid that the perpetrator would know it's obviously has to be you who did the reporting, we encourage you to report anyway, but note that you are worried about this. And if that's the case, we will hold the reports and we won't act on it until we have more reports from other people, because people tend to have patterns of behavior, right? It's never just one person. So once we get a bunch of reports, then we can act in a way that hopefully keeps people safe. So committee members and incident responders are trained. We're all trained to handle code of conduct violations and issues. So I personally have done this training 3 times at this point, and I find it really useful, and it helps me learn how to help folks who might be a little reluctant to respond to report issues, and how to deal with the issues once they are reported. If you yourself want to be trained to be an incident responder, please let us know. You can contact us at the same email address, conduct@gnome.org. We are happy to have more incident responders at events. So if you're willing to take the training, let us know. It does cost us money to do it, and we are a nonprofit, so we would sort of need a commitment that you'd be willing to actually be an incident responder at future GNOME events. But we definitely want to improve or increase the number of incident responders we have available. Okay, we're back to this slide. The how to report a code of conduct violation. So in person at a GNOME event like this one, you can talk to an incident responder. Here it's me and I think Christy. We are the 2 trained incident responders that are available here. But if you don't want to talk to us, or if you're online right now, or it's an incident that's not an event, you can email conduct@gnome.org, and that goes to the Code of Conduct Committee. There's more information at the URL there, including if, for example, one of the incident responders is the person you want to report against. Say, I did something terrible, and you want to report me, go to the website, it'll tell you what to do. And the people that are reported against will never see the report. So that's really all I have for you today. If you have any questions or any suggestions, I would love to hear it. Anything?
Do the GNOME communities have a blacklist of people that will not go invited or talk in the event due to these violations? And also, what's the consequence to the perpetrator?
We don't currently have anyone on the blacklist. We have blocked people before for a set amount of time, but currently we don't have anyone blocked. And as to possible things that can be done, that's also listed on the Code of Conduct, things that we could do, anything from blocking them from our chats for a set period of time, or revoking their foundation membership if it's an atrocious thing, not letting them go to conferences, obviously. If it's happening at a conference, we could definitely have them removed from the premises. Is there anything in particular you're asking about? Okay.
Conference sometime back.
Okay.
Yeah, just a curious thing.
Okay, that's fine. Like I said, there's a bigger list on the website, but it's not a comprehensive list, because we're always, as I say, open to suggestions and open to new ideas, and that includes ways that we can keep people safe.
I have a question regarding if the credibility of the reporter is taken into account. For example, at an event you have someone who is not a foundation member, is first time attending the GNOME conference, and they report someone from the foundation member or like a long-standing contributor. So how does the credibility of the reporter is taken into account? Second question is, when there are co-hosted events, like for I don't remember the year we hosted GNOME Asia with SUSE, OpenSUSE, and like how does like code of conduct vary when we are co-hosted with some other organization or in a bigger event where there are multiple organizations?
I'm sorry, I couldn't quite catch all of that. Could you give it to me in smaller chunks?
Okay, the first question is like the credibility of the reporter if they are not from the like foundation member, if they are not GNOME Foundation members. So how do you take the credibility of the reporter if they are complaining against, or is there any biases to that or not?
Are you? I'm just to clarify. Are you asking if a non-foundation member does something that breaks our code of conduct?
No, reports about someone
Okay, they
who
post.
has, yeah.
Okay, well, if they post something, I think it depends where they're posting and who they are. As in, if they're not a foundation member and they're not coming to any of our events and not using any of our infrastructure, there's really not a lot we can do. If they're, that being said, if they're doing something, breaking our rules in online, and then want to attend a conference, for example, we may say you're not welcome, right? It really depends. Like if you report someone because if someone is reported because they've broken the rule, the code of conduct towards a member of the committee with the power that we can, right? And that includes anything the board can do.
Okay, yeah. And the second question was like with the co-hosted events, like we did with OpenSUSE.
Okay.
Like, do you have like a precursor talk before the event that this is our code of conduct, this is yours, or there is a mutual understanding between?
So, just to clarify, you're asking if we do co-located events with the other groups? Okay.
Yeah.
Oftentimes, we will discuss in advance which code of conduct we're using, and who is in charge of being the people on the ground to take the reports. That being said, at co-located events, we would share the information.
Okay, yeah, that makes sense. Thanks.
From the reports you had this year, from which places came most of the violations? Was it like a forum, GitLab issues, or?
There's usually via like GitLab or Twitter online. They tended to be online violations. We haven't had too many in-person events yet because of the pandemic, so thankfully we haven't had any in-person issues. But I mean, if there are some, I would love to hear about it. Obviously, we would love to get the reports because we can only work together to make this. It's only as safe as we work for it to be. That sort of made sense. If you're not reporting, it's the code of conduct. Even if people aren't reporting, it's useful because I know personally there were times where I was like, look, it's not acceptable, and I know it's not acceptable, right? It's not me, right? It's not my fault that someone violated the code of conduct, right? So it makes people feel more comfortable even just by existing. But if people were to actually report the issues, then we can work together, and oftentimes we realize that these are not individual events. If someone acts badly in one instance, chances are good that they've acted badly in more than one instance, right? You don't just do it once. And maybe it is their first time, but if it is their first time report, maybe we nip it in the bud and they learn. We've had issues where we've dealt with people who were flabbergasted. They didn't realize what they'd done was wrong. And we talked to them, they learned, and they didn't do it again. So please do report. It does make a difference.
Thank you.
Anything else? If not, I will be here obviously at the conference, so you can come up and ask me any questions you like. Thank you so much.
Thank you, Rosayan, for your presentation just now.
Good morning, everybody. Assalamualaikum. So, actually, I need to clarify one thing is that I'm not a medical doctor. So, there's one thing that happened to us is when once we involved in such project in in hospital and so on, and we are start talking about this, and people are thinking that we are doctors, medical doctors. Things actually we are doing in general. Open source solution in critical care medical device integration. So my name is Azmili Mansoor. Before that, a little bit about me. I'm a co-founder of Nexo Primus in Berhad. We are focusing on this kind of services, doing integration with medical devices. While I'm quite old already, 28 years in the IT industry. I started with my first learning in 1995 with Slackware, 15 diskettes that you need when you need to install. The last 5 is for the X Windows and so on, and move on to Red Hat, Mandrake, CentOS, and then ended with Ubuntu since 2018. So this more or less typical critical care situations. I think more or less everybody knows about this, that when you are in ICU, you are even in operation theater, and with this COVID-19 that actually we are facing previously in the last 2 years. So everybody knows about this, about ventilators that give you life support when you are unconscious, and also when you are in surgery. That people are in anesthetic, they are unconscious, so they need this life support that help them to breathe. You have a patient monitor and so on. Maybe I need to show a better image, a real image. So this is a very good situation. You have a ventilator, you have a patient monitor actually that monitor your vital signs. And this one actually interesting thing that I actually just find out that actually it seems like this is a hemodialysis machine. That actually for someone that unconscious that need actually a hemodialysis. So even though hemodialysis is not considered as critical care, but in these situations we need to monitor it because that person is unconscious. So this is something interesting. This is something new for me because we didn't actually thinking that hemodialysis machine is a critical care machines. Because normally critical care machine is continuous monitoring devices. Because people are unconscious, people are sometimes unconscious or they are critically ill, so all the vital signs need to be monitored, such as their blood pressure, their heart rates, their osmometry, oxygen level, temperature, and so on. So these actually some of the critical care medical devices, patient monitor, ventilator, syringe pump or infusion pump. Syringe pump is normally for anesthetic or something that they automate or to actually pass certain substances in your, your drip, in the fluids, so that is continuously actually adding it up in certain interval of time. Instead of the nurses come and actually shrink manually inside the drip, you have a shrink pump that actually automate all those things, a CTG machine and so on. So there are two parts in critical care that actually data that actually we monitor. One is the numeric data, the vital signs, and actually the second one is the waveform, the ECG or CTG waveform and so on. So because this indicative that actually gives you some information about the situation of the patient itself. So integration with critical care devices for the data acquisition normally is over serial. I'm not sure if anybody is familiar with serial programming. So it's on top of RS2, either the connector is DB9, DB25 and so on, or over the network protocol over Ethernet. So the connector will be RJ45. So these more or less those critical care devices at the back of the these devices, you have all these integration port. Normally they are serials, even though sometimes you look this RJ45, but actually it's not Ethernet, it's actually a serial connector. So there are plenty. Then normally we just need three cables only actually for ground, transmit and receive. So and this one is one unique one. This for defibrillator. They're using like PS2 mouse port, but actually they are only the things that we consider is only 3 ports. You have to transmit, receive, and ground. So why all this trouble making all this kind of integration with these devices? Because actually you can have all these values, the vital signs and the waveform, the numerics values at the device itself. So anybody knows why? Why actually we need to integrate with these such devices? Pardon? They're not old because they actually it's not the real thing, because they are not old, but actually the sensor is actually doing the right things. They are showing you the vital signs and it's been calibrated and still it's okay. Actually, all these devices actually is called bedside devices, and the pain actually is because of that thing, because it's a bedside devices. So when it's bedside devices, the nurses or the doctors, in order for them to monitor the patient, they need to go and meet the patient itself at the bedside, in order to actually know the situation of the patient. So when we do the data integration, so we can actually transform the data and make it viewable or accessible remotely in other forms, maybe in web-based instead of directly meet the patient. We can have remote monitoring, and I think actually is one of the important things is that these devices are isolated. Meaning that if you in security you have SIAM. For event monitoring, you have all the logs coming from all the angles, from all your servers, from your network devices, and so on. So you can know from the event that happened, you can actually monitor what actually from which point actually the attacks coming. So the same thing also, more or less, if we actually acquire all these informations, so actually there is so that we can actually have studies, and this can actually give a lots of data. Then we can studies, and maybe we can develop machine learning that actually can detect that when 5 minutes or 30 minutes before somebody have a seizure or something related to that. For example, Google maybe 2 years ago announced that they can actually, with their technology, they can actually detect before somebody having 30 minutes before somebody having a heart attack. From all this data. So and what happened is that currently all these isolated devices, the data is just for monitoring of that patient, and nobody actually acquire the data and to actually use it to study for further research on big data or machine learning and so on for this kind of thing. But actually, there's been lots of research on this area. That's why it's very important for us to gather the data. You know, last 2 months, me and myself and my team, we actually subscribed to services from one company that actually take our samples and send our saliva for DNA reports regarding of our situation. And actually, they make a comparative of the reports of our results with those that actually having possibility that having DNA for certain cancer or certain disease that those people that from their own data. So this actually coming, the comparative is actually coming from a lot of data that they have acquired. So the same thing also apply for this kind of devices. Okay. So this is actually the main motivation for us actually to do it, and one of it is because of remote monitoring and for the data acquisition itself. Okay, open source project that actually that currently that we notice that actually have this such a thing. For example, is VS Capture. You can actually find it in SourceForge. Actually, because one thing you need to know is that all these devices, the ventilator, there are many brands from many companies, and there is no actually standardization, meaning that the data export, the protocol between for us to integrate. They know that every company, even from same company but different models, they are using different protocols. So there are lots of, for example, VS Capture, they cover lots of models and brands for this data capture. And another thing is VitalDB project. VitalDB is actually a project from Korea. Actually, this is what I'm talking about. Actually, this project is, they initiated this project to acquire all the data. Those who are actually using this data, they are sending in one big repository. So that people can actually reuse the data in their research. Like I'm telling previously in my slides, like for the, machine learning, for big data, because for this kind of studies, you need to have a good enough data. If not, you cannot do anything. That's why this is one of their initiatives that you can visit their website, and they are providing lots of good tools for us to actually use it. And this is actually from VitalDB. .NET, when you have all your devices connected, you actually can remotely monitor all your device, your patient, your devices. Okay. Pardon?
I've done some work on the data side related to PACS radiology.
PACS, okay. There's PACS.
Right.
Picture archive is more on imaging.
So I'm actually kind of curious about the standards, right? Because in PACS, there's usually DICOM and level 7. Right? Why aren't they used in these edge devices?
No, because I'm not sure why they are not using HL7. Okay, PACS, DICOM is more for imaging.
Okay.
Yeah, but actually HL7, actually they can use HL7, but actually if you use HL7, the data is, I'm not sure why they are not using HL7, but nobody using HL7, because it's just a raw data.
HL is a bit more comprehensive, HL7, right? DICOM is more widespread, but I'm just kind of curious, because DICOM already has a specification to collect this data, provide a standardized format.
There are some actually manufacturers actually using HL7 when you are using their their whole sets of system. For example, they have their servers that actually capture all the data, and in order for you to directly access, instead of you make direct integration with the devices itself, you are using their SDK.
Okay, maybe it's proprietary.
In this case, they will provide HL7. I'm talking about raw direct communication with the devices.
I suppose it's proprietary. Every vendor has their own. Yeah, thanks.
So, they actually, because of that, most of the time we need to do custom development for this data acquisition. So this is more or less our framework of doing it. So we have that data collector service daemon that actually the main device driver actually communicate with the machines. So in order for us to actually, for anybody to develop this kind of thing, they need two things. And of course, data export or communication protocol from the manufacturer itself, and actually they need the device. Because without the device, it's almost impossible for you to develop the device driver. Because like I said earlier, almost all manufacturers, they don't use any standards. And they are using their own protocol, and that's why you need, and it's a knocking protocol. Mean that you need to request something in some way, and then only they will respond. If you are not using the correct knocking protocol, they will not respond anything. So that's why it's very vital for you to have the documentation from the manufacturer, and second is the device itself. So that's why, for this reason, we are for us, in order for us to develop the thing, we actually purchase. If we need to develop, we need to make integration with actually such device. We actually purchase almost all the devices we need to integrate, and we purchase it from eBay. And if not, we cannot. It's almost impossible for us to develop. That's why we have lots of devices in our office and so on. So, and there are times that actually those devices is not, it's not thinkable. It's not suitable to purchase because they are big, and it's not and it's expensive. For example, ventilator. Actually, this bag of ventilator, a very big ventilator. So instead of that, what we did is that we using Raspberry Pi, we install it with Linux, and we hook it all the serial connections with the using USB to serial to all these devices, and we configure a Wi-Fi AP mode using host APD, and it become access point. So remotely, from outside of the operation theater, we can actually doing the device development, driver development outside from it. While they are in the operation or the CJ is taking place. So this actually, and to automate it, actually we develop a script that actually when the Raspberry boot, it will actually check for will automatically configure the host APD and define the SSD based on the CPU ID. So then from this we can actually have multiple. So once you integrate this example that this from two devices, from patient monitor vital sign, and this from their ventilator. Actually, it's from actual patient inside the operation theater. So when it's connected, we can actually push the data, and actually it can be viewable from any medium. So this is another example from CTG machines. Okay. So these actually things that we are using in order for us to develop the things. And do you have any questions? Okay, another thing, in Linux, there's one great thing that we have in Linux is that we have a device mode or gadget mode. You can simulate USB device by using Raspberry Pi, for example. Okay, this I just list a few things. For example, you can simulate as a G8 attendant device, as a printer device, as a mass storage device, and HID is a human interface device such as keyboard, mouse, and so on. Okay, in Pi 0, you can use Pi 0, one of the USB micro port. Actually, is a gadget you can simulate as a USD device, and for Raspberry Pi is the USB-C port. It's gadget mode. So it's quite straightforward. For example, in the case of GMAS storage, when you can actually create a container that actually simulate your storage, and then you can mount it, or you can actually load it as GMAS storage, and then when you hook it to any device, it will detect it as a mass storage. It's more or less like like your Raspberry Pi will become like a thumb drive, yes, a USB drive. So what we can use with this in this kind of situation? For example, in endoscopy machine. Endoscopy machine is you guys familiar with endoscopy machine? Actually, something they put a camera in your mouth in order to until your stomach may be lower down to monitor the situation of your internal things. Okay, this endoscopy machine. So this they are this kind of machine. They are their technologies is actually camera technologies. So sometimes they are not supporting DICOM at all. So this is the case that we are doing. So what we did is that we're using the mass storage. We simulate. We just have a Raspberry Pi, a small one, Raspberry Pi 0 with a very good case, and we have a USB dongle, and we just hook it there. This mass storage will detect it as this endoscopy machine will detect it as a USB storage. So when the operator capture the image, when they stored, it will be stored inside that USB mass storage. So when it's stored, so because we know when there is writing, because using iNotify in Linux, you can actually have notification of changes in your file system. So when we know there is changes in the file system, we will automatically write a script that will mount the loopback device, the container, and then convert it to the image, search for the image, convert it to DICOM, and send it to the PACS. Send it to PACS. So yeah, so the original usage was just to plug the USB drive. Yes, just a USB drive. So now you have something that instead of having acting as if you're using USB storage, it will actually do the same thing, but actually it will not. There is no process behind it. So by using this kind of situation, you're using mass storage, Linux mass storage, you can actually make it better. Automate all those process. So the same thing also what we are doing in one hospital in Ipoh. This is a fundus meter. Fundus meter is actually it's PC based, because like I mentioned earlier, their technology is a camera technology. So when they operate, the main pain of this is that once they capture the image of your eyes, so actually in order for the doctors or to view it, because it's PC based, either they have a shared storage that can be accessible over the network, or they need to have access to this machine. So it's become a host based solution for them. So what we did is that instead of for that is that we just developed a Python script that actually monitor the file system when it writes in the file system. So we will actually capture, we will try to find any image, and then that image we will actually convert it to DICOM and send it to PACS. In this way, they actually can, now they can access it from their PACS. PACS actually is picture archive system. And the exchange between a system to PACS is, the protocol is, what they are using is DICOM. So this one of the open source project that we are using is DICOM Toolkit. It is actually libraries and command line tools that actually you can, for example, I just list one of the things that we're using, image to DCM. So we can convert any image, for example, from the endoscopy or from the fundus meter to DCM. And then from them, we using the libraries from DCM Toolkit, read the DCM files and add all the other information like the first name, last name, patient ID, and so on before we send it to PACS. So this is more or less an example that we are using. We are an observer that monitor the file system on top of Windows platform, and actually that we will automate. We will, if there are changes, we'll know, and we know the type of files that they're going to write and so on. We convert to DICOM and then send it to PACS. So, anybody have any questions? So meaning that, you know, there's a lot of things that actually, even though it's not related to healthcare, for example, this Linux gadget mode, actually if if you go to hospital, there's lots of things that you can improvise, and their current their way of work or their things that they are having by using this, because I'm last in middle of in 90s, mid of 90s. I'm one of my favorite things is to read how to. You know, last time I had produced a very thick book for how to. So when you go and you flip and things, and sometimes, you know, when you have you need to do things, people explain it to you, the things that you can actually the problem they have. Actually, you can actually find that there are some open source or solution that actually can help, but not directly, but using it, using all this kind of thing. So for example, even the G printer is actually similar as print engine, you know. So what we did is use it in, you know, in 1995. You know, Puspacom. Do you know about Puspacom? In Malaysia, we have one company that actually do inspection for cars, commercial vehicles, for their headlight, the smoke detector, and so on. This kind of thing. Their speed. So they have some audit, because they have some audits information that actually using serial printer from their machine to print the audit information every time when any cars they actually finish the inspection. So what we did is that instead of, because you know you need to maintain the printer and all those printing, so what we did is that we throw away the printers and replace it with multi-serial card. We using Moxa and have a Linux machine. And then instead of actually they send it, we actually just develop a serial printer capture card that actually capture the data that they send, and we save it as digital information that can be searchable, instead of, you know, you always have a pile of printed audits information. So lots of things that actually you can actually indirectly use. So actually we started in this healthcare industry when we have been appointed by a GLC, governing company in Malaysia, to be part of their team for one project in one big hospital for this medical device integration. So from there we learned a lot of things that actually we can improvise the way of work in there, and started from there we set up so is that actually initiate our interest in this healthcare industry. So anyway, so it's about that. Anybody have any questions? Yes. Okay, that's a very good question. You know, we talked to MDA. You know, in Malaysia we have a medical device authority. It's like you know, a body agency that actually regulate all this kind of thing, and we've been informed. But pardon? Yes. It's not that. It's not, because it's a secondary device. It's not actually make changes. It's only read the data and just give the data back. So in this case, you don't need to be regulated, because it's a secondary device. It's not the sensor itself. No, we call it near real-time solution, because actually the data you need to have it in real time or near real time. Because why we call it near real time? Because actually we are a secondary device. The real time is from the device itself. So when they pass it the data is already been displayed at their machine. So sometimes there are 1 or 2 seconds delay between us and them. It's acceptable. Any questions?
So do you think there is a lot more prospect in this field? Means there's a lot more things to do. So means that there is a lot more career opportunities in this field for people.
Yeah, there's lots of things. For example, I just spoke to someone that hospital, one of the main the hospital is big. There are many buildings. There are many connections. For example, then there are also, for example, in X-ray machine or things that related to imaging, like our friends assess, and in hospital, normally we need to make assumptions that the network is not reliable. So sometimes, for example, an X-ray machine in radiology, that's why in radiology they have their own set of packs. Instead of they have in their data center, normally they will have it in the room itself. So that because radiology X-ray image is quite big. If you transfer it, is actually one is will take time. If the network is down, so there are possibility that you will lose the image itself. So is one of the solutions is that we can actually put maybe a Raspberry Pi that actually have a back-to-back connection that actually simulate the packs. When you have the image that actually sent to you, so instead of actually directly send to PACS, they will send to the Raspberry Pi, and the Raspberry Pi will try to send to PACS. If it's not available to send it during that time, in real time, it will try to send it maybe 1 hour when the network is available. So in this way, it can actually provide and then that Raspberry Pi or any machine that you can configure, you can make it as API, so it becomes a system itself. The operator actually can view it by accessing through the system. That Raspberry system, you can provide an interface for them to view all the image that you saw, and those images that you still pending for sending to the actual packs and so on. So this actually and things that you can improvise the way of people doing the flow that you have in hospital and so on. There is lots of things. Yeah. Yeah. Yeah.
Mixing patient records, EMR, right, THIS and all those things. It's very hard to get standardizations from all the vendors because everybody is just want to protect their domains, right? Yeah. So that is the challenge that I don't see, or we don't see people going into standardizations in the medical healthcare industry, all right? Because everybody has their own standard. It's just the same as IoT devices. You have all sorts of different wireless connections, Zigbee, whatever, Bluetooth, low power Bluetooth, all sorts of things. That is the biggest problem right now. And the thing is, my field is mostly on data management across many industries. The data management is also a nightmare, partly because nobody wants to share. So I think what they're doing is actually fantastic.
Yeah. So I forgot to mention that actually we also do some integration with pacemaker, the electronic heart. They actually not directly with the pacemaker, we call it programmer. Actually a machine that actually reprogram the pacemaker itself. So every 2 months or 6 months, all those patients that actually have pacemaker, they need to come. For example, to IGN actually to reprogram their pacemaker. So this pacemaker, this programmer, this machine that actually read the pacemaker data, actually they produce a report, and this lengthy report actually need to be actually stored in somewhere. But this machine is actually, like you said, is isolated machine. They no integration. They just print it out. So what we did is that we just using the same method, USB mass storage. And then we have the PDF, and actually PDF also you can convert it to DICOM, and then we send it to their PACS. So it is archived and can actually review it again and again.
Yeah, just a comment on standardization. This is why government comes in. This is why you have lobbying authority and all that. So somebody have to do the work. It's not free. That's
Yeah.
all. Thanks.
Okay, any more questions? Okay, thank you so much.
Thank you to Mr. Aziming also for the presentation just now. After this, alright, take it.
Okay, so we are
and this is like some bit info about me. I'm Google Summer of Code student at Genome Foundation, a Google Season of Talks Internet Waviate, which is like a vector search engine, and the Google Developer Students Club lead, also an open source contributor in Anaconda Foundation, and a front-end developer. I mess with front-end frameworks and websites, etc. You can like, check out my social profiles here. So about my project, what is Faces of GNOME. These are my mentors, Claudia Wunder and Carolyn Henriksen. who helped me build this project during my Google Summer of Code period. So the objective of this project was to continue the development of platform. So what this platform is about is like Faces of GNOME has been developed to recognize all the contributors of the GNOME Foundation. So uh, yeah, so if you see, Faces of GNOME has all types of people like designers, translators, engagement team, then the mentors, developers, mentees, documenters, and moderators who needs like recognition on some kind of platform to create their profiles, to list their skills, what projects are they part of, and recognizing their previous contributions and etc. So this initiative was led by the engagement team consisting of Claudia, Wanda, and Caroline. So I worked on this project as well. So how to add yourself on this platform? So basically, if you visit that link, that is FAO GNOME, or if you scan this QR code, you will land on a web page. There are like bit information where you can just fork the repository and then fill out the info. Then you will be like automatically added on the platform. So if anyone wants to scan it. So yeah, once you are like done filling the form and submitting the PR, this is how your profile will look like on the platform. So the first one is basic profile, where there's a profile pic, a name, then there are like the tags like contributor tag, developer, like speaker, and the events you have attended. Like I had given a virtual talk in Guadec as well, so you can customize those tags as well. Then there are like social icons there with all the social links, and since I'm a contributor at Faces of GNOME, I have my project listed there. But then if you want to customize your profile more, you can even add your blog posts in the profile. And yeah, like if you share the link to anyone in the GNOME community, they can check your profile and connect with you. So what I did during my Google Summer of Code period was creating the documentation pages and wiki pages, UI UX improvements, and experimenting with other static site generators. Since the current website is built on Jekyll, we are also planning to move on 11T or any other Gatsby or Hugo, etc. And yeah, updating a few content pages as well. So yeah, this was my short project, and if you have any questions, you can ask like anything. Thank you.
Be presenting on my topic, which was PTV GTK4 port. This was my project for GSOC 2022 at GNOME Foundation. So first of all, who am I? I'm Arden Kaushik. I guess some of you would already know me considering I gave a talk yesterday. And I am from India. I'm a sophomore at Kite India, which is a college in my country, and I'm doing BTech Computer Science. I was a GSOC 2022 intern at GNOME Foundation under the PTV project. Now PTV is a video editor which uses GTK, GStreamer, and Python. And I am also a group lead at GNOME Users Group, Delhi NCR. It's a group that I'm trying to form to encourage GNOME development. So my mentors for this project were Alex Bellut and Ritman. Their metrics IDs are also listed there. They were some of the best mentors I could have hoped for. Also, the objective was to port again to use GTK4 instead of GTK3 plus libraries in PTV project. The merge request link is listed there, and also my blog where I posted all the updates during the GSOC period, and even now I'm trying to post more updates. Now, why specifically this project? Because as we all know that after GTK4, the performance improvements are a lot. So this will make the editor more performant, and for a video editor, this is a big thing. Then it will also make it better integrated with GNOME desktop environment, because since GTK GNOME 40 has came out, the design has changed quite a lot. So if we don't update the editor, then it won't integrate like it used to back in the day. Also, it was a much requested and awaited change. As soon as I got accepted, there were a lot of mails and a lot of tweets that we were waiting for this for a long time. So that is also a good thing. It will also bring some new features, because GTK4 and libadwaita comes with some really new features which we could use for. It will also make it have a fresh UI, because as you all know, GTK4 and libadwaita looks way fresher, way cleaner, and yeah, it will also make it more modern. Now the current progress is only some things are left in the UI files, the XML files, because if we change those, then it will break the code for now. Most of the application is ported over, but we are facing some issues with symbolic icons where we had some API changes, so colors are not changing. Viewer, because the libraries we relied on for viewer are not still ported over, so we can't work on it until they complete their work. And timeline, because some of the elements are gone which we were using before, so that is also broken for now. And poppers and GTK paintables, where we are unable to fix the size. So these are some of the biggest issues we are facing right now. So these are the screenshots of the project right now, and you can see the timeline is not working. Viewer, because the GTK sync library which we were using is still not ported over, and as you can see, we are now on GTK 4.6. This is the version we are using for the application right now. And preferences window and the project settings window. So all of those are now working. It's just the viewer and the timeline which are the most broken as of now. So if you want to connect with me, these are all my IDs, and I am present on mostly all platforms, so you can connect with me anywhere. So thank you, everyone.
So okay, thank you for
Hello, everyone. How are you? Good afternoon. Okay, for this session, I will talking about between me, GNOME, OpenSUSE, and mechanical keyboard. Disclaimer: it is just like topic maybe, because I don't talk about coding or something like that. Okay, this is our agenda. The first is I will talking about me, and then my journey with open source, and then why I choose OpenSUSE, and then why GNOME, and then why mechanical keyboard also. Okay, first about me. My name is Rifki Afandi. You can call me Rifki. I am a DevOps engineer at Aruna Indonesia. Aruna is a startup maritime in Indonesia. And then I am a OpenSUSE member. And the last is new for me because I am now mechanical keyboard enthusiast. You can see that it is a collection for my mechanical keyboard. 1, 2, 3, 4, 5, and on the way to 6. Because every day I switch my keyboard. Okay. Okay, this is my journey with open source. I'm now the open source at 2016. This is first my release party of OpenSUSE lib 42.0, I think. I forget it. I'm join OpenSUSE lib release party and join LibreOffice Conference Indonesia at Surabaya, and join as a speaker at OpenSUSE Asia Summit 2018 Taiwan, and join as a speaker plus director volunteer at OpenSUSE Asia Summit 2019 Indonesia, and many event open source in Indonesia. Okay, this is advantage on Indonesia. We have many community open source in Indonesia, like OpenSUSE Indonesia, Gamescape. Gamescape is like a game and Inkscape. And then LibreOffice Indonesia, Blank on Linux, Kubernetes and Cloud Native Indonesia, OpenStack User Group Indonesia, Ubuntu Indonesia, Belajar GNU Linux, and more. If you have a Telegram, you can search example Ubuntu and just add the Indonesia, you can find the group, okay? Next, why choose OpenSUSE? Because OpenSUSE is a great community. I think it's my optional, my opinion, and great tools, especially with YAS. You can click, and yeah, just simple like that. And the last cute logo, you know, Gecko. It's a cute logo for OpenSUSE. This is a reason why I choose OpenSUSE. Okay, the next. Oh, after pandemic, we are allowed to hold the event. We call this Indonesia Linux Conference 2022 at Sidoarjo in Muhammadiyah University of Sidoarjo. This is event is attending 2000. I forget. Okay, you can like that. You can look. This is attending. We target is student. Why? Because student is the best target for finding new member or new contributor in open source. Yes. Oh, and this is OpenSUSE Indonesia activity. We held 2 times in Indonesia. We held 2 times OpenSUSE Asia Summit in Yogyakarta in 2016, and every release OpenSUSE lib we held on OpenSUSE release party. This is OpenSUSE Asia Summit in Yogyakarta. This is OpenSUSE release party, and this also OpenSUSE release party. Oh, and this is many activity on Indonesia. We are on OpenSUSE release party, Lib 15, and this is my Indonesia community, Open Source Indonesia, join Open Source Asia Summit in Japan, and we join LibreOffice Conference Indonesia and etc. Okay, before Indonesia Linux Conference held on Sidoarjo, we held on event on Indigo Space Jakarta. It's attending 35%. Yes, we're talking about open source, we're talking about open source especially, and many more. Okay, also Open Source Indonesia join activity on ELC, or we call this Indonesian Linux Conference. You can see that many students interest to our booth, and this is the organizer of Open Source Indonesia. You can see this is Kuku Syafaat, and then me, and then Mr. Yan Arif, and then Mr. Estu Fardani, and then Mr. Ari, and then Mr. Edwin Zakaria. Oh, the next, why GNOME? GNOME is easy to use. Why? Yeah, it's easy. When you install GNOME at your computer or laptop, yeah, you can use GNOME. And then many extension, you know, extensions gnome.org is many choice extension if you want. And then if you search a simple desktop environment, my recommendation is GNOME. It's the best choice. Oh, this is my machine. I have 4 machines. I have a personal computer with Intel, and then ThinkPad again, and ThinkPad again. I have 4 ThinkPad, by the way, and all of my ThinkPad is installed by OpenSUSE Lib and Tumbleweed, and my desktop environment is use GNOME. And this is GNOME event at Indonesia. If you know that, GNOME Asia held on 2 times in Indonesia, GNOME Asia Summit 2015 and GNOME Asia Summit in 2019. Yeah, we held on University of Indonesia, and this is Muhammadiyah University on Gresik. Oh, and this last my topic. Why mechanical keyboard? Oh, I think I wear my mechanical keyboard. Yeah, you can see that this is my mechanical keyboard. I call that is ergonomic keyboard because you must have 2 fingers, yeah, on the left, on the right. Okay, and why? Because mechanical keyboard can custom what you want, and then many option layout. Your layout are available in 40% layout and 65% layout, and yeah, many option. And this especially if you custom the mechanical keyboard, you can custom with VIA. What is VIA? VIA is open source tools you can get on GitHub. Okay, and Indonesia have a mechanical keyboard community. Also, this is our event. So in Indonesia, many enthusiasts for this hobby. You can see that it's many person in attending this event. Okay, only that. Thanks. And the last, save your money because it's expensive for hobby. Just very expensive, I think. Just save your money. And if you want, contact me. If you want discuss about OpenSUSE or GNOME or mechanical keyboard also, you can contact me on Telegram, Instagram, and Twitter. But my Twitter is because is single E is used. Okay, only that. Thanks. Become friend of GNOME. Okay, thank you. Oh, the question. Any question or no? Uh, 1000 VPM, I think. 1000 VPM, 1000 word per minute. Just best practice every day, every day, every day. I'm practice with my keyboard. In monkeytype.com, you can check the website. Monkeytype.com is for the tools you practice the typing. Okay, I think. Oh.
Okay, two questions. One, what is your favorite type of key? I mean, the switch. Okay.
Oh, the switch.
One, and another two. Does mechanical keyboard do improve your probably way of programming or your standard of your when you are doing coding?
Okay, the first, my favorite switch. My favorite switch is Gateron. Gateron is a fabricant of switch in the world. You can see that. I am a defense of linear switch, I think. And the two, mechanical keyboard is not increase your skill, okay? But this is just hobby. Okay, maybe if you want to try this keyboard, okay, after this event, after this session, okay, okay. If done, I have end the session. Okay, thank you.
Okay, good evening, everyone. So we are continuing our session for the afternoon. After we had a good break for lunch, I don't know, happy tummy, happy me. Okay, so we are continuing our session with introduction CSFS and debug FS by Umar Jain. So I think continue.
Thank you. I am Umang from India, and I have been long associated with GNOME since 2016, and today I am here to introduce you about two of the prominent file systems that are used by the kernel to relay its information to the user space. I usually go by UAJane handle on the internet, and there is my email ID in case you want to contact. A bit about my background. I was introduced to open source through GNOME. I was a GSOC participant back in 2016 and 17. After that, I worked for a distribution called Endless OS for a couple of years. Currently, my main focus of work is lip camera, which is like the mesa of the camera world. So I deal with lot of embedded devices, camera sensor, image processors, and things like that. So yeah, slowly from a desktop developer, I have been transitioning into the embedded world as well. So bird's eye view, what's the presentation all about? It's regarding whatever is present on your system and initialized by the kernel and it's being used by the kernel. How does the kernel actually relay its information, all that information to the user space, and how can user space basically use it or view it, maybe just to automate a few things, or like just that you are curious about what is present on your system. For developers, it can help you debug a lot of things, like what's the state of the underlying devices, like how buffers are getting passed and what are the memory is being used, things like that. So that that's a bird's eye view, and we will specifically talk about two, maybe three file systems that the kernel uses to do that. The first one is sysfs. It's a is based on RAMFS and a virtual FS. Virtual FS is basically file system interface. Like you can write your own file system with a virtual FS interface, and it will just behave like that. RAMFS means it is purely initialized and lives in the RAM memory. So after reboot, it just disappears. There is no saving of that. sysfs, the core concept is around K objects. We will look at what K objects are. To relay or to bundle any kind of device information, you need to have a hierarchy of K objects. Next is the hardware device information. sysfs has a stable ABI, so you can actually use sysfs to automate a lot of things, like use it CI/CD. We will see one of example that we use. It's a very simple example, but you will get an idea. Like if something is not ABI stable, you are like it will keep breaking if you are trying to use it. Reference counting model, sysfs has this core concept as well as reference counted whenever a resource is getting used. The K object reference count will get incremented, and when it is freed, it will get decremented. This is how the kernel knows that a device or a driver is not being used, and it will try to gather all the memory it has allocated beforehand. It is not static as it is based on RAMFS, and it's extensively used by UDEV. That is the device enumeration. Whenever the UDEV runs, it basically instantiates or discovers what are the devices that are present on your system, and HAL, which is a bit deprecated, which is stands for hardware abstraction layer. Now we'll look into K objects. So reference counter K objects main is the goal is here to bundle the information and provide reference counting. which helps to release the resources when the ref count drops to 0. sysfs has, like these K objects are represented as files in the sysfs. The structure of K object looks like this. It has a name, it has a kref, which does the reference counting. Entry, it has a K object parent as well, which is basically if you have multiple files and hierarchy, as there is typically in a file system. So it can link back to its parent. Kset, what is the set of, like there are class of drivers, so you can instantiate or put all the information there. Type and D-entry is basically something that is written after you create a K object, and it will create a file out of it. So there is I'm going to do a demo, but first let's take a look at walk around like what is there in sysfs on my laptop. So I'm not sure if you can see, but let's try to zoom in a bit. So you have, so first of all, it is mounted at root sys typically. Otherwise, few embedded system mount it as sys kernel sys directory as well. So there are few directories that are like giving the top level view. Block is whatever the block devices are there on the system. Buses are different type of buses. Class of devices. Dev and devices are basically the nodes of various devices. There are FS, file systems, module, whatever the kernel modules have been loaded on my system. That will show the, that will be comprised by the module directory, and the power management goes in power. So I think let's start with which one, maybe bus. So in the bus you can see you have sound and PCI, HID for human interactive devices. I2C bus, that is more commonly used on this, and embedded. I have a high definition audio, so there's a dedicated bus to it. GPIO bus, NVMe for the high speed PCIe Express lanes. Then, yeah, I mean, we can look at USB, like C. It's really hard to type with one hand, I guess. So USB contains, so this is one of the bus directory, and let's see how it is instantiated. So each of these entries which you are looking is basically a K object in the driver. And so the USB, it will show me what are the devices that are connected to the USB bus. So these are the devices. You won't have like a human friendly name right now, but there is a way how to do it. If you see drivers directory, you can see like a Bluetooth, you can see HID, like the interfaces for keyboard, mouse, and things like that. You will see a USB serial console, basically when we try to debug it via the serial port, any device that you can attach, for example, Raspberry Pi. You have UVC video, which is video for Linux, and like USB class, USB video class that are basically your webcams or whatever you attach to your USB port. So that's the bus directory, and let me just, for example, try to give you another. For example, if I go to maybe class, we want to see the class of devices on my system. So there are, you can see multiple things. For example, the backlight is classified as a class, Bluetooth, CPU ID, DMA, which is directory memory access, and DMA heap. I2C adapter, LEDs, NVMe, that is your SSD. Then are various regulations. So these are the type of, this is a class of devices that is present on my system. Watchdog, basically, and VLAN, ZRAM control, and things like that. So you can actually go and see what's in there and try to get understanding of your underlying system. So let me quickly demonstrate you a way how do we interact. How can one interact with sysfs? So on my system we have on my system we have a USB UVC camera, which I cannot physically pull out of my system because it's internally wired. But we'll try to mimic if an external USB camera is running and what happens if you unplug it. So if I want to simulate this through sysfs, how would I do that? So first I will find the driver, which is bus USB, because it's a UVC camera, so it is on the USB bus. What's there? Okay, drivers, UVC video. Okay, so I'll probably need to clear. So we have a couple of things here. 1.5:1.0 is my camera, and these are a few basic files giving the ID and events and things like that. So yeah, I want to show you like the camera is running right now. So this is much better. And I will unplug it through sysfs. So basically I will echo 1.5 the ID of my camera, and I will write it to the unbind file. So bind, unbind, you can see there are two files, unbind and bind. It is basically trying to unbind the device from the hardware. So if, okay, it's just a second. Probably it needs root. Otherwise, I think you can do that if you are in the video group. Just a second. If you see, the camera has stopped working. So it is basically what I have done is I have literally pulled out the camera out of the system, or running camera out of the system. So this is like hot unplug of a webcam, which is a simulated hot unplug, not a real one. It is still attached to my system. So based on this, we can write something like what we do in lib camera. We have an hot plug and hot unplug support. So in order to test that, what we do is write a test, something like so we have a test here that we run as a part of our CI/CD. It's a basic unit test. So close the DI. Initially, we are trying to find the camera, which is if there is a camera at all. If the camera is found, we will just write to the unbind the camera ID. It will literally test that the camera has been unplugged, and then we bind it again. That means the camera has been bound. So it is simulating a camera hot unplug and a plug event. And it tests the lib camera API if it is able to handle that or not. If it doesn't, it fails. So I think you got an idea how you can interact with the sysfs and like do a bit of automated testing and things like that. Yep. So sysfs, you got an idea of how the kernel sends information about its hardware to the user space. We are going to little bit touch upon the procfs, which is like how does the kernel give out information about the process running on the system to actually culminate everything into the debugfs. So simple introduction, like procfs is relaying information about processes running on your system. It is basically a snapshot of the process. That means you cannot do any I/O like that we did on with sysfs, like bind and things like that. You are writing to file. Basically, it's one directory per process. We are going to look at that as well. Init process has PID generally of 1. So it's it will look in the procfs, it will look like /proc/1. Init process, by the way, it's the first process that runs after your kernel is initialized, and every other process is a child of init. Directories are named after PID. Whatever the process name process number is, process ID is, the directory will be named after that. And you basically cannot do any I/O operation. You can just basically look around. You cannot write, I think. Huh? But you can read, yeah. So basically for just getting the snapshot, like information out, you can just do cat or things like that. But not all files, a few of them. We'll look at a few of the directories in procfs which are more, let's see what comes out of it. Let's clear the screen. So let's see what's the procfs has to tell us. Quite a bit. It's a big entry there. So these are the numeric ones that you can see are the processes, process IDs which are running on the system. And there are some symlinks and few other like versions, VM stack, uptime, which is like how much time my system has been up, things like that. So we'll see something like CPU info, which should give out what it will give out information about my CPU. CPU info. It's really hard to type. Nope. Okay. I need to /proc. Okay, so here is the CPU info, which is telling me that I run Intel i7. What else is there? There are some flags. There are information about the cores. What's the current frequency it's running with, cache, and a bit of things like cache alignment, addresses, things like that. Next, we can look at modules, which are what are the kernel modules that are loaded on my system. So you can see quite a few many. For example, there is Thunderbolt, Soundcore, Video Dev, and I think there will be. For example, I think UVC, I run it as a module, so you can see the UVC module, UVC video module there, and a couple of things related. Next, we can look at CMD line. CMD line is interesting. Clear. So basically, this is the command that the bootloader booted the kernel with. So you can see the boot image information is given, root rootfs, and like this is the quite, basically it's a quite boot. It won't give you logs. If I do it to obos, I think it will give a lot more logs about the booting process. And File systems is basically what are the file systems that are supported by the kernel. So it can support config fs, sysfs, tempfs. There are many fs like file system you can do more in detail. Btrfs, which I am running for Fuse, like for my disk, and like there is Fuse fs. So whatever the kernel supports, it is there. And proc devices, let's see what's in there. So these are the devices on my system: sound, frame buffer, video for Linux, ALSA for sound, USB device, NVMe generic, and NVMe basically SSDs. So these are character devices, and these are basically the block devices on my system. So this is a bit of an introduction for procfs. Now let's go one step further and see what procfs gives out in the form of process. So I'm going to run a process which will print the temperature of my one of the cores of the CPU and see what's the snapshot of it in procfs. So on the left, I have a process which is running giving out temperature per second, and the process ID, as you can look at the top, is 17177. And in the proc, I have that's a directory created for the process, and this is the information it is giving out for the process itself. Now let's take a look at what can we get it from that directory. So I think so. CMD line is first of all giving us what's the command line for the processes, which was just a shell script running in my home directory. What else is there? Mounts, for example, what the process has access to, whatever the mount points the process can access. So these are the mount points. I think basically everything it can access right now. C groups. It's really hard to see. C groups is the control group for the process ID. It's whatever the limits are for device access and memory access. What else can we get there? Maybe status or maybe FD. So FD is an interesting one because FD directory basically tells us what are the FDs opened by the process. For example, if you are reading or writing a file, there will be a file descriptor in this directory for that, and you can some like tests to manually interact with the file descriptor and do weird things like close them or delete them behind the scene, but it's not advisable. So 0 is basically your stand-out, I don't remember. 0, 1, 2 is basically stand-out, stand-in, or stand-error, which one I'm not sure. 255 is just pointing to the file. So if the process opens any new files or accesses any new file, the FD there will be a FD entry here. Let's see what else can we get. So you can see there are, for example, command is basically given as sh. CPU set environment. Yeah, this is also important. So environment is basically what the current environment variable the process is running with. So it's quite a few. For example, you can see the desktop session is GNOME, here, oops, log name and like things that you can basically session UTF things that you basically don't pass, but it is inherently inherently the process reads these environment, and if you are not sure what is happening, so you can basically override the environment variable and see if the changes are there. There are a few more, but I will leave that as an exercise. You can like look around and do things. So basically just launch a process, come into proc directory and play around. Yeah, so this, so first of all we saw about the sysfs, which is the hardware information to the user space. We saw procfs, which is the process information to the user space. Now what happens when suppose a driver is running and you want to get more complex information out of it. For example, the current state machine, a driver is running, so it can have multiple state machine. For example, when the camera is running, the UVC is basically in a running, or when the camera is stopped, it is in stopped, or there can be like, if I configure the camera but don't run it, isn't in configured state, things like that. So debugfs is a RAMFS based file system. That means it lives in the RAM memory. Designed primarily for debugging purposes. To enable, you need to have debug fs kernel config enabled. Simplest way to expose information to user space, for example, like the state machine information, and it is not restrictive to any hardware or any process. So you can literally put anything in there. Typically when complex and embedded device work, multiple drivers are instantiated and multiple drivers are in use, so you can have like a debug fs entry that are spanning over multiple drivers, and then you can get information at a one location. So two basic API, like how we'll see how it happens, but these are the two I will like to get the intro out. We have to create a directory in debugfs, so that's kernel API, debugfs create directory, and to emit any kind of information, you have to create a file. That's a basic premise in debugfs. So you create a file with name, mode, whatever the file mode is, file operation, and void data is here, whatever the data you want to note. The data is a void pointer. So in order to do a demo, kind of a demo, we'll look at the Raspberry Pi's video core shared memory, continuous memory allocator. This is the current driver that I'm working on, and we'll see like what's happening there. First, I will go through the driver source code. I will show you how the debugfs is instantiated, like these two APIs that we saw. And then I will do a live running demo, like when the shared memory CMA, continuous memory allocator, we call it CMA. CMA is running. We'll see what information it is giving out. So just a quick overview of when the driver is loaded, the init is called, and below that there is a debugfs entry, if you can see, that is creating the directory with the root name. What is the root name? It's vcsm cma. Then we have a function like it will give out a sm state. It will show is basically it's an internal whatever the state you want to show. So we'll look at what are the state that we are requesting via debugfs. So in the show, like this is the information we want to get out of the driver through debugfs. So we are looking at a service handle, which is basically a ID kind of thing. Resource name DMA buff, like DMA handle. Imported DMA buff, which is like to and fro whatever they imported from the video core memory, and some more handles around that. So basically you don't need to care about all of this, but this is the show function is basically whatever you need to get out of the driver. It's encapsulated into a function. And there is the debugfs create file, which we saw, which is basically a node and a file that will be created. So I'm going to run the driver on Raspberry Pi and see what it is getting for me. So we saw the directory name, which was something around VC SMSCMA. So the directory is created in debugfs. By the way, it is mounted at sys kernel debug on my Raspberry Pi. We'll go into that directory, and there will be a file called state, which is the state show function that we saw. We should be able to see what is the content of this file. So you can see the service handle, that it's a ID kind of thing, and resources and total resource count is 0 because I actually haven't run the driver itself. So the driver is not running, so it's a basic 0. Now actually let me run. So basically I have a Raspberry Pi here. It has a camera attached to it. So in a way I have just started the camera, and it is trying to access the video core's memory. Our goal is to just see whatever we expect out of the debugfs. And let's see what's the state now here. So you can see some entries have been inserted into it. So resource, so because the camera is running, it is using resources, and we can see the DMA address, DMA buffers attach. VC mapping is the video core mapping, like how many buffers you request and how much you get. So all this you don't need to care, but the thing is, while the driver is running, we are getting a live state information out of it. So it is very useful when you do embedded kind of programming, when there are multiple states and it's constantly changing. Yep, that was it. I think it was a decent introduction. Like, I didn't want to go in a fairly technical level, but just to give you an idea, like how kernel helps you to get information out of the like things, hardware, whether it's process or whether it's a driver kind of thing. So I'm happy to take any questions if you have. Yep. D-message, yeah. D-message is, yeah. No. Yeah. Yeah, yeah. The thing is, it's basically a K print. What I see is D message is a K print, and while developing, it's fine. But debug FS is mostly around if you want to merge the like the state machine information, like the debug information about the driver. And for example, if I have a customer that is remotely running Raspberry Pi, I can just ask him to provide this state. So in a way that it is not out of the kernel tree. Like kprint we usually do for kernel and then develop it, and then everything is working fine and we delete the lines. So debug message is meant to be shipped with the drivers itself. Yeah, and it's not ABI stable, so you can actually play around, but yeah, expect it to break at some point. Yep. Anyone else? Yep. Mm-hmm. Just give me a second. Proc and yeah. So the CMD line is basically when the kernel boots, you have to give the bootloader gives a certain parameters. So this is the parameter that the kernel should boot with. Okay, and you are asking if we do read write? Yeah, I'm not sure. I need to look, but by default it should. I'll try. Okay, thank you for listening.
interns of GSOC. And the first intern that will come on stage is Poya Patel. And she will be talking about GNOME CSS library.
Okay, so this button.
That one, yep. Right, go left back.
Yeah. Alright, so, hello everyone. I'm Pooja Patel. I'm a UI UX designer and a front-end developer. I'm a recent computer engineering graduate, and recently I also became the GNOME Foundation member just before the conference. Thank you. So I did my Google Summer of Code with GNOME in 2020, working on the project GNOME HID CSS library. So also became the maintainer of that project. Apart from that, I have been invited for various talks to spread the awareness about the GNOME open source, like what GNOME Foundation does and its philanthropic activities in tech. So I was invited by Indiana University, Purdue, USA, as well as some universities college in India, that is K.J. Somaiya College of Engineering. So let's discuss what is the project about. So GNOME HID CSS library, basically it is a CSS library which consists of elements and components. So the goal of this project is to create uniform websites for all the GNOME websites. So creating a uniform component and element. So that is the goal. Okay. So how are we doing this? We are also following the GNOME human interface guidelines and the visual identity guidelines to make sure that everything is included. And also we follow the GNOME guidelines that are being developed. So why are we doing this? Like if we see, then we have many websites, like GNOME has several websites. Having different designs and components. So this project aims to create sort of a uniform, congruent visual identity so that everything is consistent. Not only that, but also to make sure that it is usable, as well as people who are visually impaired or accessibility features should also be included. So that is the aim of the project. So this project will be like both usable and accessible, and the project will actually allow the developers to easily modify the current websites as well as the new websites. So it will be since it's a library, it will be easier for them to quickly develop the websites, even update the existing ones. So these are some of the examples. We have drop downs. You can see the variations that we have in all the websites. So that's one of the examples. That's pagination, that is drop downs, and that is the alert section. So how do we do this? So there are like four phases. So first is the inventory phase. So where we evaluate all the websites. So currently we are just using 12 websites of GNOME, such as apps.gnome.org, extensions.gnomes.org. Those websites have been evaluated, like all the components, even writing their attributes, like what is being used in it, how much is the spacing, how much is the padding, all of those is being noted down. Afterwards, we analyze how much does it match with the current GNOME websites, as well as does it match with the GNOME human interface guidelines. We design the mockups incorporating all of these things, take feedbacks from the design team as well as my mentors, that is Claudia Wander and Caroline Hendrickson. After that is done, it has been implemented using Tailwind CSS and JavaScript. Why Tailwind CSS? Because it's quite flexible. You can easily customize your designs, and it is fast. So the last stage is the testing. Testing where you do the visual testings, as well as the unit testings. So This is in depth about the inventory and the design. So like the 12 websites, including the focus is more about the inclusivity and keeping the essence of the GNOME websites. So the main important thing is that we follow the GNOME human interface guidelines. Okay, so this is the implementation part. Currently we are using for the documentation, we are using Jekyll, but there are some drawbacks of it, so we are migrating to Docusaurus or Hugo for the same. So when I talk about visual testings or unit testing, like testing whether the color contrast is good, the visually impaired people or other like people, they can access it well or not, all these things are covered. So what's next in this whole project? There are few components which are remaining yet to be designed and evaluated for it to be foolproof and used by the developers like a whole package. So that needs to be done. Some testing has to be done and the migration has to be done. What you all, in case if you're interested in the project, then anyone who is a programmer or a designer or documentation or testers, they can contribute to this project. Who has the passion definitely can contribute to this project. So yeah, that's all. Thank you so much. And I would like to thank the GNOME Asia committee as well as the organizing committee for organizing this event. I have learned a lot and got to connect with a lot of people here. So thank you so much.
His GSOC project, Health Reworking Sync Options.
Hello everyone, I'm Aman Kumar and my project is reworking sync options for health application. So, okay. So a bit about me, like my name is Aman Kumar and I go by the alias Aman KRX, and I'm currently a final year student at IIIT Nagpur. So my mentor for the project was Rasmus Thompson, who goes by the ID Cogi3 in both GitLab and Matrix. And the application health is available at this link. You can visit this link if you want. And health is basically a genome circle application. So health, it allows users to track their health and fitness goals. So we can add an activity like basketball or running and walking. And you can also add their weight progressions throughout, and we can also track these activities throughout the application. So we can also synchronize this. Currently, we can add this any activity or weight through add button, and we can also synchronize using various sync providers like Google Fit and Apple Health. So that synchronization features also works with different applications available at the moment. So the maintainer of the project is also my mentor, Rasmus Thompson. So initially the application was designed using the project is made with Rust and GTK. So GTK has a feature called G settings, where we can add the basic basic data of the application, user applications like in key value pair. But so initially the user data were stored in G settings file, and we can only have just one G settings file per application. So it limited the number of users per application to 1. And we cannot extend the users based if we use G settings. So the first half of my project. So my project went on by migrating the user data to database, tracker database. So the user and sync data were migrated to database, and for that a new model were created. And I also added database migrations that helped to improve the startup time by adding a fixed database version. Like whenever a database version was improved, database changes were made, then database migrations happen at that time itself. So allowing the user model to shift to database allowed us to have multi-user support, because multi-user can be created through database, but it was not possible with G settings. And new sync model was also added, so to add multiple sync providers. Initially we had only Google Fit, but now we can have support for like Google Fit, Apple Health, and Nextcloud Health. So, and improving the sync options also added the support for sync. We initially pulled the walking activity out of the sync providers. So now we pull actual activities. We can pull actual activities, and that can be provided with the sync provider, and two-way sync supports to push back to the sync providers as well. So sync changes were made for Google Fit and for the scope to add additional sync providers like Apple Health Kit and Nextcloud Health, and a new interface for switching sync providers. Like and now the future scope of the project can be to include more health categories, like tracking their blood levels and all other support. And this my personal I'm also working on adding a new application with the same stack as I used for Rust, like Rust and GTK, to build another habit tracking application that was required in the app ideas for GNOME applications. So I'm also working on that application that can be made by May, I guess. So that's my project for now. Thank you.
Presenter is Anupam Kumar, and he will be talking about GNOME network displays, Chromecast support. Thank you.
Hello. Hello everyone. So today's presentation is about GNOME network displays. This is already a GNOME app made by Benjamin Berg, and my task was to support Chromecast in this. So brought to you by Anupam Kumar. That's my matrix ID, and the second ID is Twitter, LinkedIn, GitHub, etc. everything. So I'm from BITS Pilani Goa campus, and this project started as a GSOC project, but it has since been continued from September. So my mentors Benjamin Berg at Benzia and Claudio Vanda. GNOME network displays, the app. You can find it on the GitLab and FlatHub. It's also packaged. So Miracast revision 1. A few months back, only Miracast revision 1 was supported in GNOME network displays. That was built by Benjamin Berg. Recently, while I was developing for Chromecast support, Christian Glombeck included Miracast over infrastructure support. This isn't a peer-to-peer network. That goes through the router as well. So it's in the app itself is in C, G-Object, and GTK3, but you'll soon be seeing support for GTK4 as well. So Chromecast. I think some of you may have heard about Chromecast. The recent revisions look like this, although the older revisions, 3 or second revision, should look like this. And it also comes built in Android TVs. So that's Chromecast built in. And just for the note, this application, the Chromecast support was tested on Android TV, Chromecast built in. So, casting to Chromecast. So we can cast to Chromecast right now using Google's SDK, Android, iOS, the Google apps in iOS, only limited to that, and the Google Chrome browser, the proprietary one, not the Chromium one. So they all can cast to Chromecast, videos, or the whole screen, or audio, anything. So now you may ask, you have already seen the casting on Chromecast. Then what is all this about? What is this app? What does it do? So Chromecast is a proprietary protocol made by Google, controlled by Google, everything Google. It can cast using, as I already mentioned, Android SDK, Google apps in iOS like YouTube and some other apps, and Google Chrome browser. So this implementation is our own. This is a reverse engineering effort by my mentors and me. So we can now cast our screen or videos or audio or eventually YouTube videos. That's the future scope, from a Linux device to a Chromecast supported device. A quick note here is that these Chromecast devices from Google actually verifies that this is a supported device. We actually don't verify it. You can bring your own Chromecast. So Chromecast communication. How do we actually communicate with this device? MDNS. We discovered those Chromecast devices using MDNS. In Linux, we use Avahi. Sometimes it's buggy, but it works. So after we discover devices, the device name is typically _Googlecast._TCP. So we get the IP address from there, and then we start a TCP connection. And to be precise, a TLS connection over the TCP connection. Google is mindful of the security these days. So actually there's a set port that Chromecast uses, 8009. We open a TCP connection and over that a TLS connection, and then we start messaging. The message communication starts there. So what's the format for those messages? So Chromecast uses okay, I forgot that. Protobuf. Yeah, protobuf encoding in the messages. And there's a set schema that that is backward compatible, thankfully. So there are revision 1, 2, and 3, I guess. Yeah, that's the latest revision. So according to that set schema, protobuf is a binary format. So we encode that message into set enums and UTF-8s, and then we send the message of what we intend to do. And we'll see that in the later slides. And Chromecast apps. In these messaging, we can also open apps, like in my Android TV or in any other Chromecast. We can open apps explicitly, like open YouTube apps, or maybe any app, Hulu app, or any app that is available on your device. That support is there in the Chromecast. So this is a sequence diagram for how the messaging takes place. Let's look at it part-wise. So that's the sender app. We have a sender media server and the Chromecast device. So the first and foremost message is auth. We actually fake this message and don't actually verify if it's the real Chromecast device. It takes place through the nouns and everything like that, but we just skip the response over here. Then this step is mandatory. This is connect. We need to connect to the device. This is a virtual connection, since we already have a socket connection in place, a TLS connection. The third message we send is a get status. We do this to minimize the message exchange over there. So if the receiver status says that the app is open, then we just connect to the app and play our media. But if it isn't open, we launch the app. The universal app ID key is a thing that takes the app ID. It can also be like YouTube, simple UTF, instead of complex app IDs. So after the app is open, we start the HTTP server in the sender media server. That media server actually runs Soup server, Soup 3.0. So after the server and the pipeline is ready, the media pipeline that takes your screen and outputs it on the Chromecast device. So after it is ready, not streaming yet, so we connect. Then we connect to the opened app. We are not connecting to the receiver. That's the destination we set. We open the that app which is signified by the session ID or transport ID, and then after we connected it, then we load that. Load is the command for loading the media, whatever we want to load. There we can also provide some HTTPS links, HTTP link of some remotely hosted videos, or in this case we will always do the local hosted video, since we are streaming from our laptop, from local laptop. So we send a HTTP link. This is my local ID and this is the port from which you need to stream it. So after the Chromecast gets that address, it sends a GET request on the slash path. After we get the GET request, the Soup server replies with the content type and encoding headers, what encoding to use. From here on, we handle the things to GStreamers, element multi-socket sync. This is the last element in the whole pipeline after it has been merged from video and audio. And this is sent out through multi-socket sync. We hand over the socket from Soup server to GStreamer element multi-socket sync. So after it receives after multi-socket sync sends the packets to Chromecast, it can either say media status, that means it's buffering, it's playing, it's loading, or it can say load failed. In case the content type is different from what it received, or it can't access that thing, some port error. So we have to monitor that as well. Load failed just closes the connection and you have to start again, because we can't do anything in that. Media status is discarded since it's a live stream. You can pause, you can do anything because it's just mirroring your screen. We plan to support some video playing, like local video files, or maybe you are playing Spotify and we can directly stream it to that. There we can support this media status to know if it's playing, if it's paused, or if it's buffering. But for now, it's discarded from there. Yeah. So after September, what all work was gone into this? So the initial plan involved WebRTC using RTP packets and control through RTCP. And then we shifted to HLS since WebRTC had some hiccups they used a constant IV, initialization vector, for the encrypting of packets, and Cisco's library libsrtp didn't. It used a variable thing, so we had to make decisions there. So we shifted to HLS. This was a very bad choice, since HLS stores media packets on the device and then serves them through HTTP server. This involves many I/O operations and then many latency. The HLS spec itself isn't consistent, and the official one denotes that the segment lengths can be in integer seconds. So if it's integer seconds, the minimum we can go is 1 second. So you get at least 1 second delay. So that was a no-go until I lurked around the GStreamer matrix channel and I got a very simple solution. A simple plain HTTP stream of video packets. Like, just send it over. HTTP stream that had content type video/x matroska. Matroska is a packaging format. If you have seen MKV files, that uses Matroska. The video encoding is H.264 and audio is AAC. Those two are muxed together and we send it out X Matroska. Encoding is EOF, end of file. End of file is a misnomer here since there's no file. It ends where the connection is closed when we close the connection, the end of file signal is generated. That means the streaming has completed. So the socket connection closes, the whole thing closes. So the second thing that we did was make the whole app asynchronous. So the read operation in read async in glib that showed as a would block and such things. So we removed that, and everything is now non-blocking, even the TLS handshake. So that's good. The GStreamer states state changes are asynchronous in GStreamer, so we had to take care of that. Except the null change. If we set the GStreamer to null, it's synchronous and changes instantly. So so that was done, and there were some code style defactors, compliance with GNOME styles of how things are done here. Of course, there are some limitations. The encoders that we use now are the X264 ENC and OpenH264 ENC. These are names for the GStreamer encoder elements. So these both are CPU based. This was done to ensure compatibility, but if you want, you can use NVIDIA's NVH264 ENC or the AMD's AMF something. Yeah, I don't know. So you can mention it in the environment variables when you launch the app. The H.264 ENC for the encoder, and the AAC one for the audio encoder, and that for video encoder. So EF encoding has some hiccups over here. There's a when we change the volume of the Chromecast, the stream suddenly stops. I don't know why that happens and what's the reason behind it, but it's a Chromecast bug. We have to figure it out maybe using different encoding like content length encoding instead of EOF encoding, so that even after the connection is dropped, we can simply use packet content length in the headers and it would work. So packet drops. Since we abandoned WebRTC in favor of HTTP because of certain encryption issue, HTTP just sends out streams without any care. If you receive it, well and good. If you don't, not my problem. But RTP/RTCP is a very synchronized and structured format of sending data. There are sequence numbers. If you receive packets in a different order, it will play it in the same order the sequence number is. And there's an option for retransmission of the dropped packets. So yeah, we don't get that works in HTTP, but hey, it works for now. And you can track the merge request over there, and that's my blog and some references. Any questions?
not that heavy. Let me download it first. Okay, so small topic, not that heavy, not that I think not that technical, but just want to show. I just want to share with you guys. Okay, so I'm just to share something to build openness within you. Right? Abang cameraman, sila busy sikit je. We pay our cameraman quite heavy, so I want to walk here and nanti walk here, make him busy for the last time, because he's quite relaxed for the whole event. So yeah, last time. Alright, just to share with you who I am actually. Yes, who am I? Who I am? I'm guessing most of you don't know because I'm just running unnecessary away here, there, anywhere. Alright, so I'm actually system admin. Currently working for my own company. You can say I'm freelancing, but I got I'm running my own company and then running my own project. So yeah, currently I'm dealing mostly on implementation and also consultation for someone who wants to migrate from proprietary to open source. Either they want to migrate from desktop level or to server level. Okay, this is just my proof that I am certified, which is already expired. Don't mind it. Okay, so I'm also taking photo, which is unnecessary also to share with you, but just to share with you. And this is one example of my photo. Yeah. Okay. No one don't want to clap. Anissa, you want to clap? Okay, I will. Alright, so what is actually open source? So open source is, for some people, it's a free stuff. It's a free things, which is most of us, not us. Most of people taking for granted because it's something that you can download, you can use it, but how can actually its benefit? Because that's what people didn't realize what is benefit for these free things. But like someone that I quite admire say, yeah, I think you know this guy, this old guy. Oh, sorry. So this person, which is actually, he is the one who not technically is promoting open source, but in free software, which is the reason he do what he's doing at the time and also right now is to eliminate, or he don't want anything or anyone to get advantage by locking someone in. That's why he's always promoting free software, which is end up right now is an open source. So we actually I think we are the timeline is quite long for open source to be recognized, which is actually, this is timeline around 1970 something, close to 1980s, and also introduction of Linux, which is around 1980s, which is, yeah, we came. I think we came quite a long journey to reach now. So yeah, this is actually reason why I'm stuck in 2010, because this slide is actually 2015. So I'm just recycle it. Okay, don't mind it. All right. So what is open source for me? What is open source for benefiting for me? For me, this one thing, knowledge. It's okay, this one. So knowledge. So for some people, knowledge is things that we learn at school, things that we learn that probably we interested, what interests us, what intriguing us. But we didn't realize that sometimes those kind information or knowledge helps you For example, like I think I can't remember your name lah. I can't remember your name, but this guy, the last presenter, he show us on Chromecast. Probably it will be information that I'm probably never need it, but some period of time, probably not today, not tomorrow, probably next month or next year. Next year already. It's what? Yeah, not that far, or probably happening on Christmas. You never know. That knowledge can help you out of nowhere. Yeah, because it's happened to me. I'm understanding. I'm learning Linux without any reason, just for fun, just playing around. But end up, it's my job. It's what helped me to build myself, and also it's helped me to progress. So yeah, knowledge is something that we are kind of like taking advantage. Like Robert Oppenheimer say, open society, the unrestricted access to knowledge, the unplanned and uninhibited association of man for its. You can read it. I cannot read too long because I've been running. I've been running unnecessary. Okay, so what makes things different from open source and proprietary? Obviously, I think this is the example. We not understand each other because this guy doing something that no one's know, and then this guy also doing something that others don't know, and then end up they're not talking each other, and makes something that probably not kill themselves, but will kill one of the party, which is not getting advantages, right? So yeah, why not share our knowledge? We have to share our knowledge because, for me, this is the beauty of open source knowledge. We can share it, we can open it. Like our let me recall someone. I cannot get the name. Felipe. Even though he's not here, hi Felipe. So Felipe is not here. I'm really interested on his box project, which is kind of like my kind of area that I'm focusing, which is on VM, virtualizations, something like that. So virtualization is something that makes me progress not in myself but also in my job scope. So yeah, he shares his project, and I do find it interesting, and I think it's necessary for me to learn it and to take advantage, and in the same time I'm also contribute if anything went wrong or something that not working as expected. That's is sharing, not only one way but in two way. So he's developing the software. I'm telling him that it's not working. That's sharing, even though it's not in same kind of on language, but this is sharing. Okay, but the real things I love about open source is the community. This is what the reason why I'm still staying here. This is the reason why I'm still doing things here. And for me, what I think everyone knows that I'm one of the local organizer. So the reason why I'm love doing this is because of the community. So yeah, community is something that you cannot find anything in any software, because corporate software is something that you are locking, you are staying in there, you cannot share anything. But community is something that makes the open source merrier, beautiful. Like you guys, I think you guys share your information. You guys share your. I mean, not everyone is good what they are doing, but they share. You guys share. You guys get probably share the information, and also in the same time get information. Yep, this is. You get your photo also got, huh? Oh yeah. I don't run away. This is Swimming actually. Just to inform you, this is also he's also punya one of Malaysia active open source member. I met him very long time, and yeah. Not dinosaur. Probably alligator. Yeah. All right. So that's the thing. I think community is everything in open source. You again there. So this guy is swimming here. Okay. So community is everything for me. The reason I stay, the reason I love embracing open source, not just the software, not just I can I can use it, enjoying it without paying any money or getting any new devices to launch my software. Like if you playing games, you have need to new graphic card, sort of stuff. If you want to use much more better network interface, you have to get much more expensive interfaces. Open source is nothing compare this community. I mean, this is the reality. This is the reality of open source. Okay, so what I do for the community, I mean not just community, but what I think I do for the open source community and also open source software. So the obvious reason, the obvious thing is I use it. So if you use it, you are contributing, and also you are expanding your knowledge in open source, right? So also I'm using it to playing games, this is unnecessary, which is fail. This is all thing. And also I also join to contribute in to organize event, which is this is old MOC logo. Is that yang senyum? So I also contributing the logo for the community, which is this is Malaysian Open Source Conference. I'm not sure this year. I think they recently organized the event. So I did contribute the artwork for the community, and also I do hacking stuff, which is open because it's open. It's free. You can hack it. You can open it. You can try it. It's open. So have fun with it. Don't even worry about. For example, if like I'm using Samsung, don't even worry if Samsung cancel your warranty, because open source will help you. If you got any issue, just post it in forum, or you just join any LUG, not LUG, user group, anything. They will help you, even though it's not really that live real time, but they will help you. Okay, so yeah, this is old photo, this is my first open source conference. So actually, this photo is explained. This is how I the way I contribute back to my local community to come to the event. So yeah, actually that's the thing. We I mean contributing back is not just sending bug fixes, supporting the event. Supporting event, even though it's physical or virtual, but you still support the event. That's how we can support on the community. Sabar. Okay. So I also this is a long time ago story. I'm also contributing for the documentation for Ubuntu manual, which is already obsolete. The project is no longer on the track, but yeah, I did contribute on this documentation too. This is all time. So what should you do? Never reinvent the wheel. Just work what's already available. Just keep rotating what is good. Never. I mean, it's unnecessary. If something that's good, something that proven working, end up you just doing anything else but something like this bicycle, which is useless. Also, Never work in silo. Try to work together. Yep. If you don't know, if you cannot do something, like I'm not do programming, but I do seek help from the community to help me if I got this kind of not project, but probably I'm interested on doing this. That's how I learned Python. That's how I learned PHP before. Even though I'm not really do coding, but I do understand. I can troubleshoot on PHP or Python software. Python, I actually not software, but more or less like web interface. And also try learn something new every day. Like for example, for me, I do server stuff, but I try. I'm not saying that I'm trying everything, but try something that you can understand, that you can empower. Okay, so to wrap this up, yeah, I know I'm talking too long. It's not even flash right now. It's not even lightning. So I'm trying to lightning things. This is actually mantra that my I can say my sifu, but actually he's a close friend of me. So this is Redwan. Actually, he was one of our speakers today and the first day. So he shared me these 3 mantra that I still hold strong until today. So what the mantra is? Are you waiting? No. So information is free. You have to know. People are not. You have to pay. But contributor are priceless. You have to be. All right. So that's all from me. Yep. And thank you. Okay, I guess this my not so lightning talk is concluding our session today. So I would like to. I think this is the end of the event. Kind of sad actually. All right. Before we closing our session, I think it's appropriate to let our organizer, which is I think on behalf of GNOME Foundation, I think Christy, please say something.
So first of all, I would like a very big applause for the local organizing team. They have done a crazy amount of work with a lot of dedication. Thank you so much, Fenris. Thank you so much, Saizen, and all the volunteers that were physically and also online to help us during this event. So this is like the end of the conference, as also Saizen mentioned. We would like to thank one of our sponsors as well. That's Only Office, that has been sponsoring our coffee break. Many big thanks for sure to the board of the GNOME Foundation and to the foundation itself for bringing many of us here and giving us the opportunity to join this event and to be part of it. Also, I would like to conclude with one thing. Again, here is a call for everybody that wants to host GNOME Asia next year. We would be very happy to support you during your bid. And yeah, this is all I had. And also a very big thank you to both of our keynote presenters and to all the speakers that were part of our conference. Thank you so much. Now I will hand the microphone to Fenris to say a few words on behalf of the local team.
Okay, thank you everyone. So it means like actually thanks to GNOME Foundations, 2 keynote speakers and all the speakers flying away from their countries to be here and sharing their knowledge on their talks. I really appreciate and hope the speakers and the participants are enjoying. I mean like staying in Malaysia and have a good day, and maybe we can see. Maybe we can meet it again either in Guadex or any other open source conference in the future. So I think last but not least, we have something for you guys before we end our session. Sazwan?
working. Naikkan.
Oops, sorry. Ada ni song.
Ada.
Stop. Okay, thank you everyone. I mean,
Our little gift for the organizers of the event is actually on the way, so it will be hopefully soon here with you. And I want another big applause for the audio and video team and for our both photographers, who has done an amazing job for our conference. Thank you so much for being so helpful and for being with us throughout the whole days of the conference. Thank you.
So I guess to wrap our session, we will do what Anissa loves to do. Clap! Alright guys, thank you and see you on next GNOME Asia. Apa dia?